right? So we are of one of the Fortune 500 companies. There are also other companies that you saw. So this is one way of quickly identifying which kind of company that you can work with easily. But other than that, there is also vendor checklist that you have to go through. Uh, the reason for going through this checklist is uh, s- if any one of the point is not suitable, you will feel it when you continue to work with them. At first, you will only look at I mean, when a vendor comes to your facility, you will only see a presentation, right? And that's all you see. Now, anything can go in a presentation, but at the end of the day, when you are working closely for a project, there are many, many points that you need to be available with you. Okay. For example, first thing, a company that you're working with should be either it can be a pure local company, or it should be a global company with a local presence. Okay, if ever you're working with any global company, make sure they have a person available locally, because that person will make sure the product is suitable for your country, your regulations in the country. There are regulations in Dubai, there are regulations in Abu Dhabi from the government. So it's like a law. If you cannot comply to the law, you cannot sell the product. Even if they sell it, it will not be approved by the law. So you have to make sure whoever is vendor you're working with, are they approved to be used by the local authority. For example, SIRA is the Hanwha CCTV SIRA approved? Yes. Same way you can check any vendor. Maybe they have good pricing, maybe they have new technology. It does not matter. Are they locally approved or do they have a local presence? You have to make sure. Next thing is another important factor for having a local presence is making sure the product is well suited for the environment. Okay, so uh, Middle East environment is well known for high temperature, okay, high humidity also at some places. So we have to make sure that the vendor understands the regional requirement. The testing environment is different. Okay, it's not a 5 minute, 30-minute testing. It's a long term. A camera is working 24/7 for years, right? So the environment is different. So make sure that particular vendor has got a local presence in the market, in the field, in the region, to make sure that okay, they have already supplied. For example, if you look point number 7, they already have project references, so that makes it easy for you. Okay, this product has been is well suited for my environment. Okay, data sheet is one thing, but there are a camera is not just one, it's a one device, but inside the device there are many components, right? There is the motherboard, there are the lenses, there are the components which are joining the lenses, there are seals, there are protection, weatherproof protection seals, then there are so many other electronic components. Everything has to work in accordance to your local climatic requirement. Okay, so it's not just one small device, a plastic device. So you have to make sure you have a local presence for this purpose. Okay. Next is R&D team. R&D team, this is something you definitely have to check if you're working for large projects. Okay, and you want to continue to provide supply and make sure you have a smooth supply for, I mean, commissioning and all that support. You have to make sure that vendor is having its own R&D team. The reason for that is if there is any changes, if there are any customizations required, and the vendor is not having his own R&D or manufacturing plant, he cannot make any changes for you. If he is an OEM supplier, he is just buying from somewhere else and selling it to you. If a vendor is a OEM, they cannot make any customization. So you are stuck with it, or you cannot do anything. You have to do cost saving at the end of the day for not providing some feature, or you have to spend more money to fix it. So you need to have some flexibility. It may be a small feature, it may not be a big feature, but still some level of flexibility should be available for large projects. Next is training center. Every product vendor has their own methodology or architecture of the design of the products, right? Everything is a camera at the end of the day, but yes, they can all see video, that's fine, but the way you prepare the camera, the way you configure certain parameters and the camera will change from vendor to vendor. Now, only the vendor knows their product best. So, any vendor should have their own regional training presence. It can be a dedicated training center, it can be an outsourced training center. They should be able to provide training for their product. And if you're an end user, make sure whoever is coming to your site is already trained by the vendor, right? So that gives you the guarantee that they have understood how to work on that product. Okay. Now, the there are certain fundamental things that can be same. I mean, every camera you have to configure the IP address and look at focus on the scene, but that's not the end of the configuration. There are certain things which can help make the best use of camera features. There are certain steps which you may miss. Maybe you are not getting you're not able to provide the as per the customer requirement, or maybe you're for example, sometimes the customers are looking for some features. If you're not aware of the product, you will say maybe it does not have it. So unless and until you are trained on the product, this helps you to prepare your site accordingly. All right. There is also one more point about the training. Uh, Training helps reduce the amount of time uh, correcting mistakes. If you're not trained, you will try ABC, or you'll just try random steps to to fix the camera on the field, but maybe you forgot one step or something, and there are too many cameras, right? And so there are some things if you're trained and you will be able to fix it from the starting point itself. For example, how to install. There are certain parameters for every camera type, how to install to make sure it is correctly installed on the outdoor condition. So if you forgot or if you missed it, you have to do the installation correction for every camera, right? If it is 200 cameras, you have to do it again for 200. So if it is software, maybe you can do it through the software, but some things will take more time correcting it because you have not been trained or you have not been informed. So most of the vendors give you free training, some of them pay training. For us, we are offering free training. This is our commitment to customers. Uh, but every vendor have their own policy. Next is local team. We already saw that. Experience is a vendor should have at least a couple of years of experience, at least 5 in my opinion, and or in the neighboring country, the country nearest will be almost similar climate, so at least 5 years experience they need. Okay, you cannot just say no to a vendor, but just because they are new, but you can make sure that they have understanding of they have a strong foothold somewhere in your region. Okay, so that's something you have to keep in mind. And overall, they should have, as if they are not having a local experience, at least as a company, they should have 10 years of experience as a vendor supplying CCTV. So that makes sure that the company has gone through many stages and has proved to support its customer over the lifetime, has gone through many, you can say, ups and downs in their business and have been stabilized. Next is references. We already talked about it as well. A company should have multiple references that helps you to gives you peace of mind. Okay, they are already approved by a regulator. They are already approved by the end user. They are already complying to this feature, something like that. So this something gives you that extra peace of mind. Lastly, cybersecurity. Of course, today this is a very important point. A vendor that does not have a previous record history of major vulnerabilities. All right. So just remember, uh, vulnerabilities in the software. Software is the fundamental part that is running in the camera. The architecture of the software itself is weak. That means that particular company has been wasting their time developing software which is or did not care about that software enough to fix it. Okay, and it's not about patching. Patching is just one small step, but that vendor should be sincere enough to have a very strong track record of cybersecurity. So minor vulnerabilities are okay, you can patch, but major um in the sense that is how do you say, backdoors, publicly available backdoors, and it's or certain kind of you can say you can say yeah, firmware. For example, okay, there is a vendor where you can there was a leaked password that anybody can use this master password and access the camera. So that means if I have the master password, I can access the camera anywhere in the world. There are 5 million cameras, any camera in the world I can access using the master password. That is a serious issue because that's a major vulnerability. We should not have any such record of vulnerabilities. And okay, so we'll keep it at that. There are many vendors have taken this seriously today. There are third-party certifications available like UL-CAP, Secure by Default. These certifications make sure that the vulnerabilities are closed. All right, just give me a second. Okay, all right. So let me make sure if everybody is joined in. Okay, done. Next point, global offices. This is the same point as global presence, local experience concept. Okay, so just keep this one statement in mind. A company which is having office or a company which says, okay, they are made in USA or made in Europe, but when you go to their map, they have one office in Europe and one in China or somewhere in Asia or anywhere else. So just keep an eye on these things because that means they are so where their factory is. Are they claiming they're made in USA but they are buying from somewhere else and then rebranding it? Because USA is very strict. You should have around 50 to 60% of the components made in USA to make sure it is made in USA. In Europe, some of them are 20%, some of them 30%. So based on that, they may say we are made in Europe, but they're just bringing it from somewhere else. Canada, there is no, it's even weaker, I heard. But so you have to just keep in mind, okay, where are they based in? Okay, where is their factory based in? Keep this in mind before you take a decision. Next thing, and make sure they have multiple offices. Okay, a product should be a global product. It should be working even in minus degree. It should be working in a very high temperature plus degree. So it's not just um, it not just for example, it's not just one country that the product should be sold to. Okay, if it's a global brand, it's a very matured product. Okay, handling or meeting different customer, meeting different regional requirement, and so on. So that makes the product very matured and most suitable for you. Okay, then vendor trainings. Okay, I just want to touch upon vendor trainings. Generally, there are design trainings. What is design? How to choose the camera, how to choose or size the storage. That is called pre-sales. Then, once it is sold, how to configure the camera, how to configure the server. That is called post-sales. Then, uh, some vendors have general product sessions or technology sessions, consultant sessions. For example, we are providing video foundation course, right? In this course, this is a general course. Okay, whenever we have to demonstrate some feature, I will be using our camera to demonstrate it. But other than that, it is a general course. We are not going to learn what is the how to choose model number from Hanwha. We are not going to learn that today. So there is a general training. So some vendors will have how to design CCTV solution for your hospitals, for your. So these are general trainings most vendors provide. So that's something that addressing different customers or solution providers or sales teams or end users to learn more about their technology and how to use them to make it better for their upcoming project. So these are the different types of training. Like I said, some are certified like pre-sales and post-sales. Then there are general product update trainings. Now, training lab we can see later. It's okay. Okay, manufacturing and quality reliability. And this is just a video to demonstrate uh, what are the tests that every vendor does for their product. Okay, what you get at the end of the day is a certificate, but behind the scene there is a drop test, there is vibration testing, there is temperature testing, um, surge protection testing. Then there is also this is called power. Okay, when you give higher power, more power than the camera can handle, what happens? Then accelerated life test is basically you just keep on increasing this temperature step by step, see where it breaks. Then okay, you can see waterproof, leak test, uh, durability test, image quality testing. So all these happens or is done by the vendor for every product. Okay, so usually these reports are available and on request. Okay, it's all kept as a separate document. Very few projects require it, they will supply. But otherwise, generally, these are the tests that every vendor does. So definitely, you know what I mean. If a vendor is having a very strong manufacturing process, that will be seen immediately on the project. The moment you take the camera and install, you will know that the camera has gone through a quality testing. Okay, for example, there are many I mean, we have seen some customers, they say they're getting cameras dead on arrival. Some vendors are providing no, I mean, they're giving cameras, but when it comes to the field, they have to it is not working. They have to fix some things to make it work. Some servers, the RAM cards are moved around while transportation. Some cameras by wrong power, it blew, like it failed immediately on site. So these are steps that if the vendor is not very serious, then it can have a time delay. For example, if it is dead on arrival, you have to send it to the service center to fix some things. It will take you another 3 4 days. Imagine the entire country is sending to the service center. So it will be a lot of delay, and your expectations, your delivery timelines also get affected. So we have seen in my previous experience with other companies, I have seen this dead on arrival issues. But if a vendor is having a very strong quality check background, you can be sure that it will be fine. All right. Okay. So, why do I keep mentioning about quality process? I will just take an example of Hanwha. We have a seven-stage quality process or a product development process. From the time the product there is a concept of the product, there is a seven-stage process. Then we have a background in aerospace and defense, so where quality, precision, this is all a fundamental part of the production process. Okay, then um, the top vendors. Okay, the top vendors, you will see most of the top vendors. I mean, you can request for a vendor's quality check document and other things that will give you some idea. But most of the top vendors, they make sure quality is very critical. Okay, because there is something known as field failure rate that is being measured by every vendor. Okay, so this is one way you can also ask, what is the field failure rate? Is it 1%? Is it 2%? Okay, what is the failure rate of your product? So out of 100 products, how many are bad, or how many are not working when after purchasing? Okay, so this is something you can every vendor is measuring. Now this is a sensitive information. If it is less than 1%, then it is good. Okay, 1% out of 100, less than 1%, there is a chance of failure upon arrival. So less than 1% is good. But if it is more than 1%, 2%, that means you are working with a little bit substandard quality check process within that vendor. Okay, so you can ask this also. If you are working with certain vendor, you can check, okay, verbally. They may not give it by email because it's a sensitive information. You can verbally check with them what is their field failure rate. All right, another references, we talked about big projects. One simple project is city surveillance. If any vendor has got a strong city surveillance, not one time, recurring. It's not like one time they supply and then for example, I've seen in Sharjah, they had initially they purchased from one vendor. Okay, does not mean they have a reference. After 2 years, they replaced everything. They replaced everything with another brand because it didn't perform. It failed on the site. So any customer which is having a recurring city surveillance reference, that's something you can check with, like 5 year reference, 6 year reference. Then yeah, that's a solid proof in that region. Okay, they have matched the strictest requirements, the most critical, toughest requirements they have complied. So that gives you some more peace of mind. Or one of the biggest public properties like exhibition halls, where exhibition hall is a public gathering place, right, where its security is very critical. Every camera is monitored by the police authority, not by a private security. So where the image quality, performance is very important. So if a vendor is having those kind of references, also is a value add. Okay, because public security is like constant monitoring, making sure 24/7 they are up, compared to a private security reference. Okay, okay, next is a camera breakdown. Okay, system on chip. Okay, so we are going to talk today about system on chip. If you're in CCTV business, you should also know about this because the fundamental part of a camera, there are three. One is the main brain of the camera, the processor, sorry, then the lens and the sensor. Okay, as a hardware, I'm not talking about software today, right now, but as a hardware, imagine if you're cooking a dish, the quality of the ingredients will dictate how good that dish is. Okay, you cannot buy a spoiled meat and then expect the food to taste good, right? Even if it is masked, at the end, after you have the food, you might feel sick. Same way, what is the ingredients in the camera is very important. Okay, the main is the processing engine. We call it system on chip. Why is it called system on chip? Because everything is run on a chip. Okay, if you take a computer, if you take a physical computer, there is Intel processor. Okay, that is only the processor along with other peripheral cards like display card, and then you have the USB card, motherboard, and other things, right? But system on chip is like all in one. It's got the image processing, it's got the main processor, it's got the software running on that. So it's like everything in one. That's why it's called system on chip. Okay, it's got memory, it's got processor, it's got other components. So that's why it's called system on chip. So the system on chip is like the main brain of the camera. All right, there are uh, very few companies who supply this equipment, this component. Okay, system on chip. Few brands, you can name 5 to 6 brands. They make their own system on chip or their own processing unit. There's, you can say chipset. The other brands they buy from third party. Okay, third party is also okay, but the there is something called outsource. So it is the technology they buy from someone else. Okay, okay. I will come to the difference between these two. Now let's say, for example, there are 5 6 brands. One of them is Hanwha. They make their own chipset. Okay, so that means that chipset is having some level of future proofing. Okay, it is having some level of expansion capability. Okay, comparatively, if a vendor is buying from another third party supplier, that means there is something called they are buying the over, they're paying some extra money, right? They're giving, it's a cost. Okay, so in that case, it's like this. They will buy for they'll say to the chipset supplier, I need ABC features. Okay, the chipset supplier will say, yes, my chipset can give you ABC. Okay, done, supplied. Now, cameras have been started manufacturing with that chipset. Now, tomorrow you need a D, feature D. Now, when you go and check the chipset is already full. The memory is already full, the processing capability is already full. Now they cannot add feature D. So there is that kind of limitation when it comes to OEM. All right, the chipset uh, can have that kind of block. Okay, it cannot allow you to expand that functionality. So that is possible because they are buying it from someone else. Okay, that chipset supplier will charge a variation. They will say, okay, if you want to add this feature, I need more money, and so on. Same with any OEM supplier. If the OEM supplier has a, I mean, is already supplying the camera based on the first initial agreement, then then if you ask for one more feature, they're gonna charge variation. Then whatever feature you are asking, then you cannot pay a variation uh, to the OEM. It will be in millions of dollars, so it will never happen. You have to wait for the next batch of new models to be released. That's why some vendors, when you ask a feature, they will tell you we will release in the next series. That means they cannot control the OEM, that they don't have the budget to give variation to the OEM to accommodate more features. Okay, that's why they will tell you, okay, we will release in the next product after 3 years, after 5 years, or after 2 years, something like that. Okay, now back to the system on chip. Okay, having your own system on chip is good. Next thing is, uh, system on chip is the main cost of the camera. So as much as possible, if it is bought from someone else, they try to buy the least specification just to meet the feature requirement. So for example, let's say you have a 5 megapixel camera. Okay, uh, the camera will give you 5 megapixel. Okay, done. If you want another 5 megapixel from the same camera, the chipset will not be able to do it. It will only give you another 2 megapixel. Okay, so if you want two streams, dual stream, one 5 megapixel full frame, another 5 megapixel 10 frame, the chipset will have a limitation. So this is where the uh, you can say this is where you will see the difference between a good quality chipset and a low quality or low performance chipset. Next, analytics. it's also dependent on the chipset. WDR performance dependent on the chipset. How much of bandwidth compression you can get, it's dependent on the chipset. Now, it's like it's the brain of the camera. Every single function that is being processed is done from the chipset. Okay, when you buy a laptop, you buy i5 processor, you buy i7 processor. So depending on your application, you buy a certain processor, i3, i5, i7. Same way in the cameras, there are different processors. Why does a vendor have high-end camera and low-end camera? Okay, but just remember, you can buy a high-end 4K camera and a low-end 4K camera today. So the resolution has does not really matter anymore. Okay, today a 4K camera is not a very high-end camera. No, even a low-end camera can do 4K. But the main thing is what more can it do at the back end? How good it can process the image, how good it can perform in low light, how good it can do WDR, how much analytics I can get. All right, then how much of better compression I can do, how accurate how accurately it can apply all the settings, how quickly it can apply all these settings real time. So how quickly the image can be processed. All that is dependent on the chipset. Okay. Now, next two major component is the lens. Lens, if you use a good quality lens, you will get a good quality image. Then image sensor. Image sensor, let me see, where is that? Yeah, image sensor. So lens, then image sensor. The light is captured by the lens and it falls on the image sensor. So this is also an important component. Okay, so three components are key: lens, image sensor, chipset as a hardware. Then of course you have the software uh, part that we will see later. Okay. Now regarding the lens and image sensor, I will be covering it in the coming slides. So just will keep that on hold for now. Okay. Next, every camera, there are many components that you have to keep in mind. Camera body. A camera can be plastic. If it is indoor, you can use plastic housing. If it is outdoor, you have to use metal housing, aluminum, or any other kind of metal, alloy or something. Then stainless steel housing. Stainless steel is more heavy, so it is used in corrosive environment, food factories, like manufacturing factories where there is water presence, resorts with seashore environment, or there is certified housing. Excuse me. Okay, what is a certified housing? Certified housing is used for uh, oil and gas or coal mining facilities. All right, oil and gas. Oil and gas is offshore environment or maybe onshore, where in the atmosphere there is oil and there is a presence of oil or combustible materials, right? Petrol stations. Okay, there is in the atmosphere there is some level of combustible materials. Mining, coal mining. There is there is dust, coal dust. So even if there is a small spark, it can cause you can say it can ignite the place and it can cause fire. So once again, X proof. So those kind of places, you would probably use cameras which are called explosion proof, which looks like this. They look stainless steel, but they have something known as certifications called ATEX ones. Okay, so these have third-party certifications. Third-party certifications from ATEX or IEC, so that is called certified housing. If you're using in oil tankers for the ship containers, you should have Lloyd's certifications. So there are third-party certifications required. That is why it's called certified housing. Okay, it's a global certification. Okay, next, stainless steel we saw. Then the bubble of the camera. Bubble of the camera is this lower bubble. The bubble of the camera, it can be standard or it can be vandal resistant. Okay, now, uh, what is vandal resistant? Let me explain this with a short video. Okay, so here you go. On the left side, let's say the guy is taking a stone and he's using a standard glass. Okay, broke immediately. Okay, but if you're using a different kind of material, did it even crack? No. Okay, now he's gonna take a hammer. The first material broke. Second one, okay, not second one, is using the hammer with the same force, it didn't even crack. All right, so it's typically called polycarbonate or standard glass. Okay, now back in the day, glass was used, but nowadays, most of the bubble part, this bubble, lower bubble part, is vandal resistant because even if a person is taking the hammer with whatever amount of force that he can put, try to break the glass, he cannot damage the bubble. That's why it's called vandal resistant. The highest rating is called IK10 rating. Okay. Next, people confuse IK10 with IP rating. There is something known as IP rating. This is different. IP rating is for weatherproof. Can it protect against water? The second digit is for water. The first digit is for solid. Solid is what? Dust. So if 66 means it is dust tight, no dust can enter, then another 6 is here against powerful water jet and heavy seas. Good enough. So anything to do with rain, IP66 is more than sufficient. So there are two ratings available, IK rating for vandal protection and IP rating is for weatherproof protection. Is that clear? Okay. And IP66, the first digit is for dust. You may have IP06. That means zero protection against dust, good protection against water. Okay, does not mean it is better. You need 66. Both numbers should be 6 and 6 for Middle East outdoor environment. If anything less, you don't have to use it outdoor. You can use anywhere else in indoor environment. In Middle East, dust, fine dust, very common. Nowadays, water, there is no way to say what level of water is. There's no big dust and big water, small water. There is just water. So when it comes to water, you just need straight away a good amount of water protection, that is 66. Okay, your camera is not going to be immersed in water for sure, but anything other than that, rainwater, water jet, cleaning, it should be able to protect. For dust, you can say you cannot go with one, two, three. We cannot dictate the size of the dust. Directly go with the dust type. You don't need any dust inside. Okay, so hope this is clear. You need at least IP66 for any CCTV camera installed outdoor in Middle East. Then system on chip, the brain of the camera is responsible for resolution, frame rate. Uh, can the camera give 2 times 5 megapixel, 125 frames, another 10 frames? Depends on the chipset. You know, many vendors they'll give you 5 megapixel for live view, but if you ask another 5 megapixel for recording, they will not be able to. They will tell you maximum 2 megapixel, maximum half megapixel. So that means the chipset is not powerful enough. Number of analytics. Cameras may have 10 analytics, but they will tell you only one or two can be running at a time. So that is all the issue of chipset. Okay. So just to provide 10 analytics, they will have 10. But at the end of the day, you cannot apply all 10. So that you have to keep in mind. So when a vendor is providing their own chipset, their own control on the chipset, you will not find such limitation. For example, again, I will take our brand Hanwha. We have 15 or 16 analytics in the camera. Everything can be run at the same time. Plus, you can add more some third-party analytics also. So these are limitations which we, as a vendor, if we are developing our own chipset for, no, we will not do that. We will not have such limitations. But if it is outsourced, there is a chance because that chipset cannot handle. That is the low cost chipset. They just want to prioritize image quality first. They don't want to prioritize analytics. So, these kind of compromises the vendor will do. Next is software. The software that is running on the camera, the how good the software is. This you cannot, as a pre-sales, as a design engineer, you cannot directly tell this. Uh, but one good way to check is maybe you can check their uh, you can check their training manual, or you can check their camera manual document to see how the interface looks like, what are the features in the interface, and so on. If you take, for example, I have taken here. So right now I have logged into the camera. So I have used, I'm using an IP address and I have logged into the camera. So as soon as I log in, I'm able to see the live video. The camera did not ask me to download any software to see the live video. Okay, I can do a snapshot. I can take a manual recording through the web page, Chrome browser. I can do a recording just to check. Okay, so these are some things that you can do seamlessly. Okay, this helps in the for the person who's on the field, to save some time. Next, the way the menu is arranged, use a time, categorization, settings, network. So video quality, let's say, when I make some changes here, I can immediately see the impact on the camera after and before, how the camera is responding. These are certain things that help vendor. For example, motion analytics. There are different ways to do motion. Sometimes you will see many vendors, they just have a button called motion, enable motion, and mark everything and click apply. That's it, no further control, no fine tuning. So here you can check the current level of motion. So some guy walked in, so there is some motion. You can customize the area which you want to cover, look for motion. You can increase and adjust sensitivity, duration. You can exclude certain area. You can configure the minimum size to detect the motion, so small objects will be ignored. You can have multiple zones. So these are some. This is the software running in the camera, by the way. Now this, for you to directly know, it's very difficult unless you have a demo camera. You cannot check. But how good the software is, you have to be I've seen some vendors where you click some button, nothing happens. They have all the buttons, all the features, but it does not really do anything. Okay, so that's something you cannot really see it on a paper. You have to experience it. So make sure you work with a vendor which is having a good software team. Okay, if there is a bug in the software, it's a headache for you. Then On-with camera vendor should support on-with. We will see that later. Then other parts of the camera are alarm input, microphone input, uh, image stabilization sensors, IR illuminator. What is IR? We will see that later. SD card, memory card for recording on the camera itself. These are certain additional add-on features that you can have from the camera. Okay, now we'll take a break in 5 minutes. Before that, let's see what are the components in the camera. Okay, first thing, camera depends on light. Okay, light. It is converting light to electrical signal. Now, which part of the camera is responsible for gathering light? Lens, receiving the light. Where is the light focused on? On the image sensor. The image sensor converts the light to electrical signal. After that, there is image processing, then converting the image into H.264, H.265 in a compression standard, video stream, and then it sends it over the network. If there is SD card, it can record on the SD card, but otherwise it just sends it over the network. Okay. Now, sensor and lens, both, there is something that you have to keep in mind. Some vendors, they will give you 4K sensor, but the lens is not capable for 4K. They in okay, resolving. So resolving power, there is something called as a resolving power of the lens. I don't want to divert too much, but uh, resolving power is how clearly the camera can differentiate the objects in the scene, okay, through the lens. I mean, how clearly it can pick up the details from the scene and throw it on the sensor. So uh, simple statement. If you have a 4K camera, the lens should be 4K supported. Okay, that is one way to put it. If you have a 4K lens, the sensor should be 4K support. Okay, there was a time when we have seen, uh, there was a rush to give 4K cameras, right? So back then we have seen some vendors, what they do, they have a 4K sensor, but the lens is 2 megapixel. Okay, so the quality will look like 2 mega because the lens is 2 megapixel support lens. Okay, so you should make sure the lens also is 4K support as well as the image sensor is also 4K. Okay, then yeah, next is in the sensor, there is still a confusion with many consultants, CCD and CMOS. CCD is the first image sensor. It is used for analog cameras, typically used in analog cameras. In IP cameras, you hardly will find, very rare, you will not find any CCD sensor. You will only find CMOS. CMOS is used by almost every IP camera brand, even cameras used in mobile phones. So because of that, CMOS, there is a lot of improvement in technology, a lot of investment in improving the CMOS sensor. So in that way, CMOS currently in supersedes in terms of capability, performance compared to CCD because of the level of advancements done in CMOS. Secondly, CMOS takes lesser power, which is good because when you have a IP camera, uh, you have limited amount of power, right? PoE, you can only give around 12 watt or to 15 watts. So when you have those kind of IP cameras, you need to reduce the power as much as possible. So that is one factor for reducing. If you use mobile phones, you have battery, you're dependent on the battery, so you need to use as less power as possible. That's why CMOS is also preferred. So mostly any megapixel camera, 1 mega, 2 mega, 5 mega cameras, nowadays you'll only see CMOS. Okay, WDR. Okay, we'll take a break and then we will continue in some time. All right, let's continue the session. Okay, WDR. This is something you will hear very frequently in CCTV systems. In every CCTV vendor also will commonly talk about WDR. Now, the reason why we talk a lot about WDR is because as long as there is sunlight, so as long as there is sunlight, you can expect uh, the camera to have this effect, which you see on the first picture. The window is too bright and the person inside cannot see properly. Okay, so you can basically, yeah, the window is too bright, so you cannot see what is outside, or it will be you can see who's outside, but the image will be dark, so you cannot see the person standing inside. Or this is an entrance, you cannot see the person coming through the entrance. So this either one of them will be a side effect if the camera does not have a WDR feature. Now, what a WDR feature does, it combines these two exposure frames. Okay, it takes two pictures from the same scene. So this is the scene. It will take two pictures of the same scene, one at a long exposure. That means it will open the eyes for a long time, make sure all the details are captured. But sadly, the area which is bright will be overexposed. The window is overexposed. Then it will take another picture. It will close its eyes, reduce the exposure, at not completely close. It will try to close as much as possible, just allowing very little light to enter. And in that time, very little light is entering, so it can see the outside area, outside the window, but inside is dark because as a human, we don't emit light. We are only reflecting the light, right? We are not a light source, so we are dark in the image. So what the camera does, it takes two pictures and then it blending like a mixie jar. It blends these two picture and combines the best part of each image. So the first part outside is very bad, so remove the outside. In the second part, outside the window is very clear, so merge the second part for the windows and the inside part from the first one and creates an optimized image. Okay, now this is done for every picture. If the camera is sending 25 frames, it is doing this process 25 times. So it is capturing 50 pictures, and every two picture it is merging them together and gives you a single picture. So this is the property of feature of WDR. This is how almost every WDR camera works. Okay, so if I have a WDR scene here, my window is very bright, right? So again, window is super bright. Inside the image is a bit dark. Okay, compared to the amount of light available, it is looking very dark. So when I activate the feature called WDR, then immediately the indoor scene is becoming brighter. I can now see outside also. See, I can see outside the window, and the indoor scene is also much more brighter. How is that possible? Because I activated W. If I turn it off, then it's dark and I cannot see how to. What happens? The camera is trying to reduce the amount of light entering into the camera sensor. That's why inside is dark, because there's too much of light. The camera is thinking there's so much of light. It's a computer, right? It's not a human being. It cannot think like us. So when the camera looks at the scene and it says, oh my god, there is a lot of light, that means I need to reduce the exposure. So automatically it will reduce. When it is reducing, the inside area becomes dark. Outside is still too bright. Cannot see. So we have to reduce the exposure more to see outside. So what it does, if you reduce the exposure more, you cannot see anything inside. So what it does, it takes two pictures, combines them together and to give you a single WDR image. Okay. Now, some vendors do combining of two pictures. Some vendors can combine three pictures. Some vendors combine four pictures to give you a much better image. So we can do two, we can do four. Some vendors do two, some vendors do three. Okay. So it's not exactly how many frames you do really makes a big difference. The idea is, in order to do a WDR image, you need at least two. So if you are providing a WDR image without this concept of long exposure, short exposure, then that is not a true WDR, TRUE, true WDR. That's why you will see some vendors, they want to say they are WDR by adding some confusing words: electronic WDR, digital WDR. That means there is no concept called mixing of exposure. They have no such concept. They just try to do some manipulation of the image brightness to give you some WDR scene. That will not solve the problem. Okay, you need to have a true WDR. All our cameras are true WDR. You have to make sure any brand that you want WDR must be specified as a true TRUE, true WDR, or it should be mentioned as multi-exposure camera. Okay, then how do you measure the WDR value? WDR value is measured in dB. So for example, if I try to measure the light level in my office, directly under the light source is around 1000 lux, but when I go under the table to the sunlight, it is going to 10,000. So when I go near the window, you can see it is going to 10,000 plus. So sunlight is having a lot of, when I go under the table with some amount of light, it goes to uh, 20, 30 lux like that. So lux is the measurement of light. Now in a scene, if you take a scene, there are two levels of lighting. One, for example here, in the office, there are some light. So that is some amount of lux level. In just one part of the scene, there is 10,000 lux. Inside the office, there is 500, 600 to 1000 lux. So if you see the ratio of difference, if you see the ratio of difference between indoor and outdoor, 1000 and 10,000, the ratio of difference is very high. Then you can call it a WDR scene. Okay, the ratio of light in the same scene. Okay, not if the camera is looking in the scene, that means for the camera, this is the scene. In this same scene, if there are two different lighting condition of very big difference, contrast or lux level difference, that is a WDR scene. Then a camera needs a WDR feature, because a camera does not know which light to focus. Should I focus indoor? Should I focus outdoor? It does not know. So if you use a WDR, it will balance the lighting and make sure you get an optimized image. So this is called creates optimized WDR image by combining two frames to give a single frame. Okay. So you can see without WDR, outside is just too bright, and with WDR, you can see outside you can see the details of the tracks and so on. Okay. Then, yeah, in order to do WDR, the camera has to capture more frame than it can give. So, just a second. So, for example, if a camera, yeah, the one more thing, the ratio of light, too much bright and too less light inside, that 10,000, 1,000 lux. So outside is 10,000 lux, indoor is maybe 100 lux. So that ratio of difference, if the ratio is very high, the WDR value will be very high, 120. So that is measured in dB, decibel. That ratio is measured in dB. A camera which is at least 120 dB can handle almost every lighting condition. Difference 150 dB can do more. Okay, so a WDR, how do you measure? Like IP66, IK10. So this is the measurement: 120 dB, 130 dB, 140 dB, 150 dB. 150 dB is the highest in the industry. Now, how is 150 dB achieved? The camera captures 120 frames and it will merge every four picture as one picture. Take the best part of four pictures, for example. So here we go. One, two, three, four. Four pictures. It will merge in four different exposure, right? It takes four pictures. It will merge it as a single picture. Take the best part of each. First one, the doll is okay. Second one, background is okay. Third one, the clouds are okay. Fourth one, maybe some details not really there. So it will combine the best of four and give a single image. So this is how 150 dB is achieved. It combines four pictures in one single picture and gives you 30 frames. All this is done in the camera. It's not going to increase bandwidth or storage or anything like that. It is, at the end of the day, it only gives you 30 frames. Okay, then highlight compensation is a feature opposite of WDR. Okay, if you see the background, there is no light, but suddenly there is a car coming with headlight. So it compensates, it just masks, it just blackens the highlight area. So it's the opposite of WDR. Okay, why does it do it? Why do you need this feature? It can help because when there is a sudden bright scene, the camera is not confused what to do, and the area near the light source is also affected. So the area near the light, you can see this is called bloom, 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 blooming effect. So nearby pixel is also damaged or overexposed. So maybe number plate is cannot be seen. So camera, you can tell in the software to mask the white light. It's called highlight compensation. Next is a low light. Low light is okay. Just a second. Low light. Okay, before we go to low light, let's see. Uh, let's see no light. If there is no light, then you need something known as IR camera. Camera which has got LEDs. These are IR LEDs. When there is no light, I'm saying zero light, completely switched off. So when the light is completely switched off, what do? You take your mobile phone, turn on the torch light. Same way, the cameras have their own LEDs. It will turn it on. Or it has a sensor. When the light is below that level, it will turn on the LED. But this LED is not white color. It is IR, infrared. So we cannot see. It is a red color part of the spectrum, so it is invisible, but the cameras can capture it. So when the camera captures, it gives you a black and white image, because IR, infrared, does not have a color spectrum. It is just shades of gray and black. So uh, it will be black and white, or it's called monochrome. Okay. Now let's say there are different ways of doing IR. If you have a PTZ camera, for example, there is something known as zoom IR. So when you zoom the lens, automatically the IR range also will zoom in and out. So this is a common technology now. Some of them don't have, but some premium brands you will find this is called zoom IR or variable zoom IR. Depending on the lens level, the IR light will adjust accordingly. Okay. Okay. Now, what is the thing with IR? IR, how is it shown in the camera? It is shown in the camera datasheet as IR viewable length. What is the IR distance? How long the IR can handle? You take a mobile phone torchlight, you cannot stand in 100 meters, right? You can only stand maybe 5 meters. Only that's the distance. So same way, even the IR LED, they have a distance limitation. So camera can go 70 meter, some camera 50 meter, some camera if the lens is small, it will be 20 meter, 30 meter. So at least you will see 20 meters and so on. Okay. So this is how IR is measured. Now, w- let's say customers don't want black and white image. They don't want black and white. They want color picture. If you want color picture, then you have to give, you cannot give IR light. IR light will give only black and white. So if you want to give color picture, you need some amount of white light. Now, how do you provide this if there is no option, right? So in that case, there are certain cameras, they are called low light cameras. So even if there is a little bit of light, maybe somewhere from the street light, or maybe there is some small night lamp somewhere, even if there is a little amount of light, the camera is extremely sensitive. So it has a very large sensor, image sensor, 1 by 2 or 1 by 1.9. Most of the image sensor is 1 by 3, 1 by 2.8. So this one is bigger. So this number, if it is smaller, it is big sensor. DSLR camera, it's called full frame camera. It is usually, it is not, it is just 1 inch. It is not divided by anything. So it's those cameras give you much rich image quality because of the sensor size. So for us, let's say there are some cameras with bigger sensor, and there is also cameras with uh, F number. F number is 0.94. What is F number? Uh, the capability of the lens to open the shutter to receive the light. Okay, or sorry, iris. The capability of the lens to open the iris, how big it can open. Smaller the number, more wide it can open. If the number is very big, opening is very small. Okay. Okay. Now, most of the image f number lens is 1 by 1.2, 1.2, 1.4. This is like the mass production. Very few lenses have zero point 0.9. Almost very few can count with hands. So they can give you very bright image even in low light. Why you need this in the first place? Because you have a scene, you want to capture color image on the right side. The same scene with a low light camera will capture color image, whereas a non low light camera will capture black and white. You just want color picture, real time, 30 frames, object can be moving fast, that's all okay. So if you want a good image quality at low light in color, then you go to extra low light. Okay, some vendors they call it dark light, starlights, moonlight, and this light, different names they call it. Simply, they are all referred as low light camera. Okay, there is two words, low and light. You need some amount of light, but it can be low. Zero light, in that case, you need IR. If you have zero light, you need IR because camera needs light to see. Just like us, if you switch off the light at night, we cannot find our way back, right? So a camera requires some light, either IR light or pure white light, visible light. Okay, now next. Okay, before we close, the last topic for today is resolution. Okay, then everything else is all additional feature. Camera can have SD card, camera have some level of additional installation friendly features like Wi-Fi option. This is not a Wi-Fi camera. It is just we can plug some dongle to do configuration. So when you plug the dongle, during the time you can access the camera over camera's Wi-Fi hotspot. You can connect and check the camera view. So you don't need to carry a laptop or something. So these are all additional features. They call it convenient features. All right. So it depends based on your camera model. You will find all these features. Okay. Next is resolution, focal length. Now, every camera there is something called as lens. How far it can see, how low it can see. Okay. For example, you take the camera back, which I was referring to. Now I can adjust the zoom level of the camera or I can zoom in. So I can zoom in, I can zoom out. I am doing this remotely. So this is called motorized zoom. There is a motor in the camera and I can do remote adjustment. I can do it from here remotely, right? So this is called adjustable zoom, motorized zoom. Uh, and because I can adjust that lens, it's called varifocal. So if you go back to the data sheet, you will see a focal length zoom ratio 2.8 to 12. That means the lens can be 2.8 or it can be up to 12. So I can move the lens between 2.8 to 12. 2.8 to 12. You will always find f-stop. You can see here most commonly lenses have only 1.4. You take any camera in the world, you will see 1.4, maximum 1.2. So the low light cameras are less than 1, so to allow more light. Okay, so that's the low light camera. So here back to this topic, lens 2.8 to 12, motorized varifocal. Varifocal because it is adjustable. Motorized means I can do it remotely. I don't have to go and just like you have a DSLR camera, you don't have to rotate by hand. You can do it with a motor. You can do it with a button on the web page of the camera. You can do it. So that is motorized varifocal. Okay, is written here. Remote control via network. I can control this. It is also referred as remote zoom. Okay, this is normal camera. So focal length. Focal length. The lower the lens, wider the coverage. Higher the lens, narrow the coverage. You can see 600 mm. The coverage is very narrow. So if someone is standing, uh, here we go. If someone is standing here, and if I use 600 mm, he's not covered. Even if I'm standing here, it cannot cover. I have to be within this area. Only then it can see my face or the person. Okay. So higher the mm, more the focal length. There are cameras with very high focal length. For example, pan, tilt, zoom. This is called PTZ. Pan, tilt, and zoom. So, Scott, okay. So let me see. So here, basically, I have a camera here. I can zoom in around a kilometer and so on, and I can go up, down, left, right. I can move around. This is called zoom. This is very high zoom, right? Then I can pan. This is called panning. I can move up, down, left, right, go left, go right, go up, go down. This is called pan and tilt. So I can adjust all this remotely. So they are referred as PTZ cameras. So you can see this part, it goes left, right, up, down, and so on. Pan, tilt, zoom. These cameras are good for operation, tracking people, and so on, or checking at a very far distance what is happening. Some accidents have happened. Used in city surveillance. Okay, so these cameras can have very high focal length to capture kilometers. Okay, all right. So then there can be lenses which is fixed. You cannot change the lens distance. So for example, so this camera, okay, it's fine. Okay, let me take another camera, XNV6011. So I have a camera here. This is called XNV6011. The lens is built in 2.8 mm. Built-in lens 2.8 fixed lens. That means it is fixed. You cannot really move the lens. So in this case, it is not a varifocal lens. It is not a motorized. You cannot do any adjustment. It is fixed. Okay, mostly you will find 2.8. Why? The lower the lens, the lower the lens, more lower the number, the more wide you can cover. Again, you go back to the live demonstration. The more I zoom out, the more lower I go, the more wide I can cover. If I increase the lens, the more I go, the less area I cover. So most of the time when you go for fixed lens, you will find a very big, small number, sorry, you will find a very small number. What is the purpose of that? So you can cover as wide as possible, 2.8. It can cover 109 degree, okay? So if you see here, uh, from from the center, it can cover a total of 109 degrees. Okay, so that is what mentioned here. 2.8, 109.7 degree, and if you go to 12 mm, 26 degree. So wide angle. So that's why when you go with fixed lens, most of them will go with 2.8, 2.8 or 2.4 or 3 in that range only, most of them. Okay, now whenever you design a CCTV camera, you have to keep in mind what is the objective of the camera. Every camera has a purpose. If you put on a scene, you need the camera to do at least one purpose, that is detection. That means it has to detect any activity within the scene. What is the scene? Where the camera is looking at, that is the camera scene. In that scene, if there is any activity, any movement, any change, operator sitting in the control room should be able to detect. In order to do that detection, the camera should provide or supply at least 20 ppm. What is ppm? Is called pixel per meter. Pixel per meter. So you can see here, in order to do detection, you need at least 25 pixels per meter, or so 20 to 50 pixels per meter. So the camera, that per meter, you should allocate around 20 pixels at least to give you some level of detection. Then we have recognition, detect, identification, and strong identification. First, we will see identification. Identification of an unknown individual. When you are seeing a person for the first time, he is called an unknown individual, right? You need to see, look at him as clearly as possible, as close as possible, as clear as possible. So that is called identification. So, for example, if I have another demonstration here. So let's say this is 500 pixels. 500 pixels is strong identification. So when I'm looking at the person for the first time, I can see his face very clearly. I can see the number plate very clearly. So unknown object, unknown person, very clearly you can identify. 300 pixel, still good identification. So the criteria is up to 250 pixel per meter, you can get identification. Now if you go lower, then you cannot identify very clearly. If you don't know this person clearly, you can be confused. Maybe some other guy from the same place may look the same, or his family, relatives, anybody can look the same. So that is not identification. So that is the next level, recognition. Okay. Now you have identified him. Let's say he's Ahmed. Now once you identified him, now you can recognize. I know this person. I already identified him. This is Ahmed because same shirt, same pant, is same physique and all other things. So that is called recognition. Once you identified somebody, you do something known as recognition of a known individual. So first is unknown individual, then recognition, known individual. The expectation of pixel is less for recognition, very high for identification, very high for strong identification. What is strong identification? When the light is very poor, then you can say I need strong identification because there is no, for example, in this picture, imagine this is if there is no sunlight, very little lighting, maybe I cannot see clearly. In that case, you have to go for strong identification. Okay, so whenever there is a first point of entry into any building, you go with identification. Whenever there is once you have identified, everywhere else you do recognition. Very large area you can do detection. Why? Because when you do detection, for example, this is detection, this is good enough. You just want to know who's in the wandering in the parking area. You just want to know what's happening. That is called detection. Just detect some guy coming in, car coming in. So one camera is enough to do detection. You can cover a very big area. But when you do identification, very little area you can cover. So detection is better cost saving, but you cannot compromise all the entrances. For sure you must do identification. Now there is a tool, we will see how to do. Before I used to use a third party tool. I will show you both and then we can close for today. Okay, now while it loads, I will also open the third party tool. .com. So the website is called jvsg.com. Just go to jvsg.com. Then you can click on camera CCTV lens calculator. Once you go to the lens calculator, then you can see this 3D drawing. Okay, now on the right side, you can see 105 pixel per meter. 105, it is recognition. Uh, so the face looks a little bit blurry, not very clear. You can only recognize, you cannot identify. Okay, here this tool is a third-party tool. You can choose any vendor, any specific model, then automatically all the details will load. But if you're not sure, you can just leave it as blank. And most of the cameras they have 1:3 or 1:8. You have to choose. Focal length we will see 2 megapixel. Now the guy is standing at 15 meters. The camera is installed at let's say 3 meters, and the person height is around 1.8 meter. Okay, these two we don't have to change. So focal length. Currently the camera lens is 4 mm. So imagine if I make it less, I can sorry, if I make it less, I can cover more wide. You can see this image becoming wider and wider. Okay, so this is becoming wider and wider, and you can see the horizontal angle 84 is becoming bigger and bigger, 90° and so on. Okay, you can see wide angle. But the issue is the pixel. You can see the face even more blurry now. Target is now 60 pixel. Before it was 100, now 60. So you have to zoom in to get more pixel density. So still recognition. If you want to identify this person at 15 meters, the camera should support at least 12 mm lens. 12 mm lens. Camera should support 1 by 2.8 inch sensor, or okay, sensor not a big deal. You need 12 mm lens and 2 megapixel resolution at least to capture a person. Okay, sensor, by the way, it is important to the point that you should not go all the way to 1 by 6. These are very poor lens sensors. 1 by 3, 1 by 2.8. Try to stick between these two. These are the globally available camera sensors. Okay, okay, here 12 mm lens, then I can see the person clearly. It's identifiable, and the angle of horizontal coverage is 25°. Okay, 25°. What is the meaning of 25°? That means from the center of the camera you can draw a line. Above is 25 by 2, 12.5, 12.5. So this total angle is 25. So how do you draw this? And yes, okay. How do you draw this? So you take the camera first and then you draw a line. Let me change the color. Okay, first you draw the camera, then you draw a line where the person is standing 15 meters, right? So this should be 15 meters. After that, then you have 24.8°. So that means let's say 25. Here draw 12.5. Here draw 12.5, and at 15 meters you cut it. Okay, eraser. Sorry, it should be here. Yeah, 15 meters you cut it. So this is the same thing. This cone is the same thing. So you take the camera, draws to center line for 15 meter. The person is standing at 15 meter. 25° divided by 2, 12.5, 12.5. Draw the cone. So that is the coverage of the camera. Okay. So yeah, there is also IPVM calculator. Let me just go to that. I've not used it much, but there is IPVM calculator also. You can refer to the calculator. Okay, let it load. Okay. Before that, Hanwa, we also have a calculator free to use. Okay. When you go to the website, just change to English, and after that, click on Toolbox Plus. Toolbox Plus. Once you go to Toolbox Plus, how do you figure out which lens to use for a camera? Let's say my door is 10 meter. Okay, it's a bit slow here. Okay, now once you land on the toolbox, there is just remove all the filters. New, take any, let's say, 2 megapixel camera, and take any camera which looks like this box. Okay, and click on map. Okay, now I'm going to upload a map. Let's say I have a floor drawing, desktop, first floor, and I, I need to calibrate the drawing. So let's say this door is 2 meters. I'm going to mention this as 2 meter. Okay, done. Now drag and drop the camera. So at the entrance, I need I need to figure out what lens is good to get identification. So just you can put your mouse, you can see 200 pixel, 250 pixel. Near the door it is 200, not identification. So either I can move the camera or I can try to increase the tilt angle and okay, so here, so I need, if I want to cover both the doors, I need to keep somewhere here. Okay, okay, so here if I put my mouse 280 pixel near the door, so if this particular camera can now look at with 9 mm to 9.9 mm, I can get identification. Okay. There is another method, FOV. You can also do this. Uh, Again, let me go back. And you take any camera, click on field of view, make the guy at let's say 10 meter, and height of the camera, let's say 2 meter. Can adjust here, and you can just drag and drop. You can check how much you can reach. So I can get 286. So 286 is anything above 250 is identification. So this is one way to check, okay, any camera with 11.5, 12 mm, I can get identification at 10 meters. So if it is 15 meter, can I get also? Yeah, but I need 15 mm lens for this model. So this is one way of figuring out. Every vendor will have some level of calculator like this. You can check as well. Or you can ask someone to do this and export the report and give it to you. So that can also be done. So these are free tools. You can use it for your own purpose. So this mapping thing, it's free also. You can upload multiple maps and export as a report as well. All the cameras in the map will be shown and so on. Okay, so this is the concept of identification, recognition, detection. Every camera has a purpose, either to detect or to recognize or to identify. Okay, just to summarize, we talked about working with vendors, make sure they are reputed vendor, they have global presence, they have a local presence, they have tested products and project references. Then we talked about chipset, we talked about different camera components, IP66, IK10. Then we talked about the uh, image in terms of WDR. We talked about highlight compensation. We talked about IR for zero light. Then we also talked about low light. Then we captured lenses, fixed lenses, adjustable lenses called varifocal lens. Then PTZ camera, pan tilt zoom camera. The objective of pan tilt zoom is for very far zoom to do investigation or tracking of people and so on. And then we talked about DORIS standard, detection, observation, recognition, identification, strong identification. DORIS, just the first word of everything. The standard, every camera has a purpose, either to do detection or identification. When someone asks you, can this camera see 20 meter? Yeah, it can see even the moon, but or the sun, but does not mean it can do detection or recognition looking at the sun. That's something you have to be careful about. So you have to tell at 20 meters I can get recognition. At 5 meters, the same camera, okay, I can get identification. So this is the actual word, because you can see as far as you want, but what can it do as a minimum? Detection, recognition, identification. So this you have to keep in mind. Okay. All right. If there are any further questions, you can post in the chat window. You can expect an email from me with a very simple quiz link, just covering questions about the topics we covered, very basic questions. And that's it. And I will see you tomorrow. And have a nice day. If you have any further questions, you can post in the chat window or Q&A section. Thank you.